Hello there. In this video, I want to cover what I think is an interesting little tidbit about how if statements work in Python versus how ternary operators work in Python. So let's start with creating an example. Let's go from, and I'm going to use the timeit library to, first of all, I want to make a comparison of how long some of these things take in terms of time. So I'm going to create a little setup, which is a way of putting some code in place that will run but not be timed ahead of time. So let's just say foo is bound to the value of none. And we're going to write out two different code examples here. The first code example of how we might deal with none, supposing that it needs to be dealt with, let's say is if foo is none, then assign to the value foo 0. Let's say that that's just a desirable default value when it happened to be none. And then we'll write another code example here that uses a ternary operator, where we'll say foo is bound to the value of 0 if foo is none, else foo. Okay. Let's just double check before we actually do anything else that works. That's lovely. Great. So now I might want to collect the times. Let's say that time 0 is equal to timeit, and we're going to use code 0, and the setup here is equal to the setup. And then let's also duplicate that for time 1, for timing the code example 1. So we have these two different times, and I'm just going to compute it as a ratio here. So I happen to know that code 1 is the slower of these two. So I'm going to write it as a ratio so we get some x factor slower in terms of a number greater than 1. Who knows why I want to do that? I just do. Oops, and actually this is a bit of a typo. We want to take the ratio of the times. So let's take time 1 divided by time 0. And let's print that result. So, any predictions on which one's going to be faster or slower? I think I already told you, right? So let's just do it. Any guesses on how much faster or slower? I'll take a guess now and you'll see. Okay, so in this case, about 1.47. I've also seen it be down as low as like 1.2 and 1.3, depending on the system I'm running this on. But, there we go. It's kind of an assortment of values to give you a sense. And remember, we're running timeit with the default arguments for the number of times that it runs. And I think it runs, I don't know, many times in terms of sample size. What is it? Oh, yeah, it's like there's a million. Runs a million times. So you know that that's the ratio of the aggregates, which is not the same as aggregating the ratios per se, but it does give us a rough idea here of there is, just through monotonicity properties, this fancy word for basically stuff being bigger when the inputs are bigger, that we should have it be the case that, reliably speaking, time 0 is less than time 1. So that really begs the question here of why is code 0 faster than code 1? I would like to know. So let's take a look at importing the dis library. That's going to show us, it disassembles Python bytecode, and conveniently enough, if I remember right, it will also show us the disassembled Python. It'll show us basically the instructions in the Python bytecode, but in a somewhat human readable-ish format. Sorry, it's dis.dis. And let's just take a look at this first one. Here we've got that it resumes, and this is referring to, I believe, resuming into the Python session. And then it has this load the name foo. Offhand, I'm not sure what the pop jump if not none is, but maybe we should look at that sometime. Maybe we should go through the disassembly library here, the dis library, and understand more of these commands. But we don't need to see the comparison we're about to make. And then we're going to load a constant of value 0 here, and we're going to store to that the variable, store that value to foo, and then return the constant, and then we return const, I think, back out of the session. So now what if we also, beside that, put number 1? Well, not beside it, but below it, I guess. And run it again. So, and maybe just for clarity, let's print I don't know, some dashes here. 100's too many. 100's a little bit too many, but now we can see a separator. So what's different? We got resume, we got load name, we got this pop jump if not none. Sure. I mean, that not, pop jump if not none is probably just the branch point of whether something is none or not. That's what my guess is. Not that we need to know right now, but I am interested. And then we got load const 0. We got load const 0. We got store name foo, then return const, And then we get to a difference where the next thing that happens here when we take another step out is that returns const again. Not sure why or what that is for exactly, but we do know that it continues differently in the example with code 1 where we got load name foo and store name foo again. So there's additional instructions here that make it different from the just pure statement version, and then return const. I don't know for sure, but my intuition about this is that, look, I mean, the if foo is none statement is a statement, and so I feel like it's intuitive that it has to do one fewer variable assignment there, whereas the ternary operator is going to give an expression, and that expression, I think, at the interpreter level actually has to give some kind of value rather than just another instruction or something like that to make sense of this, doing this extra load name and store name for the interpreter. So anyway, in any case of whatever interpretation is the correct interpretation of these disassembly instructions, I think it's interesting that demonstrably there are more instructions involved with the ternary operator, which leads me to think about use cases. When would I want a if statement versus when would I want to do a ternary operator? And I think the clear case for ternary operators is where inserting some kind of expression into something is the right answer. You don't want a statement, you want an expression. In other words, you want something that specifically evaluates to a, value. And a statement isn't going to itself be evaluated. So the whole distinction between statements and expressions I've noticed is a little bit language dependent, but to be clear here, I mean, all of these are in some sense statements. They all have semantic value to the interpreter, but the ternary operator is additionally an expression. Okay, hopefully you find that to be an interesting little tidbit about Python, and if you are interested in more content like this, like, share, and subscribe, and of course leave comments below about things you're interested in related to Python. And with that, I will catch you in the next video. Take care.